Hello everyone, how are you? I hope you are all doing well. So, in today's lecture, we are going to study the law of sines. Basically, this law also comes under the vector addition, or we can say in vector subtraction. So, and since it is having the term sines, that means it will be having the some we can say some angle of sines, so that it will be one equation which will be having three angles of sines. So let's draw that. Let's say there are two vectors, a vector and b vector, and which are having angle between them theta. So let's draw them. Let's say there is one vector a, and the another vector is, let's say, the vector b. And the angle between them is theta. So this is the angle between them, and it is theta. Fine. And as per the law of parallelogram law of addition, the resultant vector will be nothing but the diagonal vector. Okay. So this is vector B, and let's say this point is P and this point is Q. And this is the point O, or we can say the origin, or the we can say the same initial of both the vectors A vector and B vector. Now let us draw the resultant vector, and we will denote it by R. Okay, so this will be the resultant vector. Now let us connect this, and let's say this point is S, and now we are going to connect the point S to point P also. So it will have the form of parallelogram, like this way. Now we will do some we can say the improvisation in this diagram little bit, so that we will get the, okay. So we can see that in a parallelogram, the opposite sides are parallel and equal to each other. So here OQ and PS are parallel to each other, and so the angle between the horizontal and the PS vector will be theta, as similar to the earlier vector, which was between A vector and B vector. Now we are going to draw it vertical, or we can say the horizontal, from the point S to this the horizontal vector. This is the angle of 90-degree, and let's say the name of the point is N. And now we are going to assume some angles here, like let's say this angle is alpha, and the above angle is beta. This angle is beta. Fine. That means the angle between, okay, let me denote the resultant vector also. That is R vector. Okay. So finally, we can say that the angle between A vector and B vector is theta, and the angle between resultant, which is R vector, and the A vector is alpha, and the angle between B vector and the resultant vector is beta. Now we are going to derive the law of sines. So for that, we are going to use the right angle triangles. Okay, so one more thing is remaining here. So now we are going to put a normal on the resultant also from the point P. Okay, let us draw that. So if we draw the normal, wait a second. Okay. And this angle is 90 degree. And let's say the point is M. The point M is on the resultant vector, which is OS, or we can say the R vector, and it is making the angle 90 degree. So MP is the normal on the OS. Okay. So now from triangles, and one more thing here, by using the law of parallelogram, we can say that the resultant vector by parallelogram law of addition, we can say that resultant of A vector and B vector is given as R vector equals to A vector plus B vector. Fine. Okay. Now from the triangle, we can say from the triangle OSN, or we can say the triangle ONS, what we can uh, find out. So let us take this triangle from triangle. Let us take the triangle SNP. Triangle SNP. What we can find out from SNP, let's find out the sine theta. So sine theta will be sine theta from the triangle SNP. Sine theta will be the, we can say, hypotenuse, sorry, uh, height upon hypotenuse. So that is Sn upon Ps. So it will be Sn upon Ps. So from the diagram, we can say that Sn is the height and Ps is nothing but it is, since OQ and PS are parallel in parallelogram. Let us write that since OQ vector is parallel with PS vector. OQ is parallel with the PS vector in parallelogram. In parallelogram, then what we can say that OQ equals to PS vector equals to B vector. And since the magnitude of B vector is B and magnitude of A vector is A, and the magnitude of R vector we are going to denote by R. So from the above equation, we can get that Sn equals to PS sine theta. And finally, we can say that Sn equals to, since PS is the length of uh, PS vector, so it will be B sine theta. And let's name the equation number 1. Fine. So now we are going to take the another triangle. Fine. That another triangle is the triangle ONS. The triangle from right angle triangle ONS. So if we take the right angle triangle ONS, then what we will get? we will get that sine alpha sine alpha equals to Sn upon os. Sine alpha equals to Sn upon os. And from the diagram, we can say that it will be equals to Sn upon r. Since os equals to r is the resultant of the vectors a and b. So finally, we will get that Sn equals to r sine alpha. And we will name the equation 1. After equation 1, it is equation 2. So from equations 1 and 2, we can say that, or we can say the combining equation 1 and equation 2, what we will get. Since both are equal to Sn, so we can say that b sine theta equals to b sine theta, or we can say that r sine alpha equals to b sine theta. And if we rearrange the equation, then we will get that r upon sine theta equals to b upon sine alpha. And let's name the equation as equation number 3. Fine. R sine theta equals to b sine alpha. R sine theta, sorry, R upon sine theta equals to b upon sine alpha. Now we are going to take the triangle SMP from triangle SMP. What we can say? Triangle SMP. Or we can say the triangle PMS also. Both are correct. So sine beta. From that, we can get that sine beta. Sine beta is again height upon hypotenuse. So here the height is PM. PM and hypotenuse is PS. PM upon PS. So we will get PM upon PS. And as we know that PS is PM and PS is B. Or we can say the magnitude of B vector. So finally, we will get that PM equals to B sine beta. And let's say this is the equation number 4. And now from triangle, we can say the triangle PMO. Triangle PMO, what we can get? The triangle PMO, we can get that sine alpha equals to PM upon OP. Sine alpha equals to PM upon OP. And from the diagram, we can say that since OP equals to A, or we can say the magnitude of A vector. So finally, we will get from this above equation that sine alpha equals to PM upon A. And finally, we will get the equation PM equals to A sine alpha. And let's name the equation as equation number 5. So now from combining equations 4 and 5, what we will get, because both equations are equal to the PM. So from equations 4 and 5, we can say that A sine alpha equals to b sine beta. A sine alpha equals to b sine theta, sorry, b sine beta. And now again rearrange the equation, we will get that A upon sine beta equals to b upon sine alpha, and name this equation as equation number 6. Now from equation number 3 and equation number 6, what we will get, since both are equal to the equation, we can say the term b upon sine alpha, both the common is the term is common, b upon sine alpha. So finally we will get the equation as, from equations, from equations 3 and 6, what we will get, we will get a equation r upon sine theta equals to a upon sine beta, a upon sine beta equals to b upon sine alpha. And this is the law of sines. This is called the law of sine.